Already we know enough of ideas, so directly after collision I'll show it. So here what we are, I'll assume the particle will have velocity v1. And now what about this rod? Will it rotate about center of mass or will it rotate about its own center? It will rotate about its own center. But sir, previous problem we have shown, if the particles get stuck to the rod, then so what happen, you should consider angular momentum about the center of mass here. The particle will not get stuck to the rod, and if the rod set free to rotate, what happen? It will rotate about its own center. But sir, you only said the rigid body will rotate, set free to rotate about center of mass. You see, particles get stuck, what will happen? The center of mass of system will not be at center of the rod. Your particle will not get stuck. In elastic collision it is equal to 0.5. So definitely what you can say that one, the rod is set free to rotate, so it will rotate about its center. Then applying conservation of linear momentum, initial momentum equal to final momentum. Initial momentum mu, final momentum mv1. This is 4m. So one equation. Then applying next the conservation of angular momentum. About which point? About any point? Or about only? About only, because after collision the rod will rotate about O. So therefore LOZI is equal to LOZF. LOZI mu L by 4 clockwise. Then IO, that of the particle, mv1 L by 4 clockwise. That of the rod, IO omega 2 clockwise. Why there is no angular momentum due to V2? The velocity of the rod will intersect axis of rotation. This axis. Axis is what? Z axis passing through O. So therefore this V2 will intersect, velocity V2 will intersect axis of rotation. So therefore only due to rotating motion we have angular momentum. Solving this, U L by 4, V1 L by 4 plus this will be 4m L square by 2L into omega 2. 4 also will get eliminated. L will be U V1 plus L omega 2 by 3. Equation 2. How many unknowns are there? V1, V2, omega. We need one more equation. Can apply conservation of kinetic energy? No. Inelastic collision. So what I'll do, I'll go for line of impact. There's a point P. Anything directed towards right, let it be positive. Then E is equal to velocity of point P minus velocity of particle plus V1, but initial velocity of the particle U minus 0. E is equal to how much? 0.5. Vp should be equal to V2 plus L by 2, L by 4. It should be L by 4. Solving 1, 2, 3 will get the required answer. It's an inelastic collision. So what are the possibilities? Elastic, perfect inelastic, and inelastic. So when that, so it's all about like particle gets stuck, you have to be careful. Then you have to, it will rotate about center of mass of system. Particles will not get stuck to the rod. The rod will rotate about its center. I think there's a thing which if you can identify, I think you can manage. Rest of everything, okay, you know. And conservation of angular momentum. What about an axis passing through O perpendicular to plane? So initial angular momentum, mu L by 4. Try to see, I think, can you remember last week we stressed a lot, no? How to find out angular momentum of a particle. This idea, L by 4, this is mu L by 4. Then finally, mv1 L by 4, ml square by 2L into omega 2. Mass of the rod is how much? 4m. That we are substituting it here. Anybody please solve it. The end answers will conclude. We'll start with a rod. Afterwards, Arpan, I'll bring other rigid bodies. Are you getting the methodology of the rigid body, studying rigid body mechanics? First, we'll begin with the rod. Then what happen? I'll bring triangular plate, semicircular plate. I'll bring circular disc. Different rigid bodies will bring it, and we'll see what conditions will come. This week, all of you have to put maximum effort because now everything we know it. By today, I think you know everything about rotation mechanics. You know torque, angular impulse, angular momentum, linear momentum, collisions. Almost the total mechanics is what you know it. So the numerical can be of any kind. Please give the value so that some of the things I'll interpret here. Or can you solve it? I'll write only velocity of point. What is velocity of point A? What is velocity of point B? B2 minus. They can ask you any of these things. Again, instantaneous center. So for that, what you should do is to search a point where the velocity will be zero of that particular thing. That particular point can lie inside or outside. Now, similarly, I want force exerted by one off on the other off. V1 minus U by 23. I'll push it. Let me write answers first here. What do you mean by negative sign? It will rebound. 6U by 23. Yeah, that will be. And omega 2 you can. $18 U by 23 L. Okay, yeah, thank you very much. Now, see, these are our answers. Negative sign comes, what does it mean? It will rebound. But sir, we assumed it. No problem, let it be. Because the velocity can be positive or negative. So what does it mean? Particle after collision rebounds. What do we? What is the negative sign? Particle after collision rebounds or retraces path. In the question, if they give directly after collision, the particle comes to rest. Tell me what you are going to do here. You are going to write V1 0. Very easy for you. How to get velocity of any point V and VB like this. Now, what is the force exerted by one off on the other off? Let me show that here. Force exerted by one off on the other off. The center of mass of this will be how much? 2m omega square L by 4. The center of mass of lower part will be 2m omega square L by 4. Why 2m? Because there's a rod of mass 4m, no? And this length is how much? L by 4. So altogether what happened? This upper off will exert a force on the lower off. And I'll give some other color. Upper off and lower off, I'm just showing the different shades. There will be a stress in the rod. No, get into the thing. So this is the, okay, got this one. So like this, so you know omega, you know omega 2. Okay, there's omega 2, no? Put that. So there is a force exerted by one off on the other off. So many things are there. Say that's what all the ideas, what all you learned in mechanics will be here. So what is the type of motion the rod will describe? Translatory and rotatory motion means the rod will be center of mass will moving that and it will be rotating. So what is the type of motion? Translatory and rotatory motion. That's what the rod will describe motion here. So force exerted one off of the rod on the other off is 2m omega 2 square L by 4. This you have to omega 2 value, what all you use there, you substitute, that will be the force. And nothing but there is centrifugal force, no? Simplest thing. So where do stress will be maximum here at point O? So where is possibility of the rod breaking up at the point O? That's what they have to take care. So why we are discussing all this, say when you go to machines, you get so many situations like this. I think you look at the machine, no? There'll be a rotating rod will be there. So where the stress will be there maximum at point 2. And I think some machines are there where continuously open one rod will come and strike the other rod for that motion. So there, this particular discussions will come into picture. So keeping all that machines in the mind, no, just we are introducing basic ideas. So what is the possibility of this rod breaking up at point O only maximum? Because the stress at O is maximum. So any possibility that the rod will break up at point O only. The first probability is it will break up at point O only. So they may test you with questions like this. So after impact, where is the probability of rod breaking up first at midpoint? Because here the stress will be maximum, here the force will be maximum. Okay, this is about the introduction. Tomorrow we'll discuss some other very good numericals, all application. I'll stop the class here.
So can you scroll down a little?
Okay, ma, yeah.